Welcome. Thank you for joining today's webinar, Predictive Maintenance, the Next Evolution. This webinar is co-hosted by ISA and Maverick Technologies. I'm Michaela Cooper with ISA, and I'll be hosting today's webinar. But before we get started, I would like to review just a few housekeeping items and let you know how you can participate in today's webinar. First, in regards to the poll questions and question and answer session, we do have 3 poll sessions throughout the webinar, and when those poll questions pop up, we ask that you enter your answer into the poll feature on the WebEx navigation, which is on your right-hand side of your screen. These are completely anonymous. They're not going to be shared with everybody in the WebEx, so feel free to join in and participate. Also, we do have a Q&A session at the end of this webinar, and to submit those questions, you'll also type them into the WebEx navigation into the Q&A box on the right-hand side of your screen. To try to keep all the Q&A questions in the same area, we ask that you only put the Q&A questions into the Q&A chat box. There's a separate chat box. Those are for any other questions you have for me, the host, or any other miscellaneous questions. So let's try to keep those separate so the presenter can have all those questions all in one place. Also, if we run out of time in the end and we're unable to get to your question, the presenter's contact information will be given at the end of the webinar, and you can reach out to him directly. Second, for those of you who just joined, make sure that you're on mute. We want to respect the time that this presenter has put into this webinar. If you would like to see the phone and audio broadcast connection instructions again, please refer to the confirmation email I sent you, or if you go to the top left-hand side of your WebEx screen, you'll see a tab labeled Event Info, and some of those connection instructions are included there as well. And additionally, once this webinar closes, a survey should pop up in your browser. It's a really short survey. It may take you 90 seconds to 2 minutes. We look at those responses, every single one of them. We are very interested in how this webinar went for you and any sort of feedback you have for us. Okay, I believe that takes care of some of our housekeeping matters. To get started, I'd like to introduce our presenter, Tim Goecke. Tim has over 30 years of manufacturing experience with expertise in operations technologies and automation controls. For the last 10 years, he was heavily focused in the data collection and predictive analytics technologies and applying them to manufacturing assets via the leading technology OEMs. Tim's expertise goes across continuous, hybrid, and discrete manufacturing. Welcome, Tim, and this will be a great webinar. And I'm going to go ahead and pass it off to you to present.
Okay, very good. Thank you, Michaela. All right, so first of all, I just wanted to thank all the participants for your time and interest. I also wanted to thank ISA for the opportunity to allow me to come in and share some observations I've had since coming back to manufacturing about 6 months ago. I was a lifetime participant in manufacturing in various capacities. Got a little frustrated with manufacturing, and back in 2014, because of the lack of speed of adoption of things like software as a service and advanced analytics, I went off into the supply chain realm. Got a little tired of that, came back, and since then, this particular subject that we're going to talk about today and the speed that it has evolved since I've left is just stunning. And it's my pleasure to share this with you. I am not a data scientist. I'm not a machine learning, artificial intelligence expert, but I am a data practitioner, and I've seen the power of what data can do from an advanced analytics perspective, and I'm excited to be here. So with that, I want to start out with just a historical perspective. So from a predictive maintenance or just maintenance in general, what's been the evolution? Well, there's run to failure. Basically the bottom of the evolution chain. Then, the next best thing is calendar-based maintenance. So, that bearing gets a squirt of oil every 30 days. Then there's, the next evolution is usage. So instead of squirting the bearing with oil every 30 days, now you do it based on hours used. The next, maybe next best thing could be, condition-based maintenance, where now you've relying on sensor feedback to give you, an idea as to when an asset's reached a specific threshold where it needs maintenance. And then you have the reliability-centered maintenance, which is a very thorough, very professional consulting engagement for an asset. It's proven to be effective. But, I will maintain that all these fall short of the goal. And the goal for anybody running an operation with assets is to have those assets never break down in an unpredicted fashion, because it's very disruptive. Well, to date, that has not been achievable. All right. So, just some observations from other companies. Boeing has gone public saying that 85% of the equipment fails in spite of calendar maintenance. And Emerson's gone public saying 63% of maintenance, scheduled maintenance, is unnecessary. So they're, you're scheduling it, but you're over-maintaining it because either the usage isn't there or the asset's not ready for it. So lots of room for improvement. So along came advanced analytics back, about 10 years ago, and it showed a lot of promise. There's some downfalls to it, though, and this was my experience when I left back in 2014. This is what was available, and some of you attending may have experienced this and maybe haven't seen what's new out there, and we'll talk about that during this webinar. But basically, the downfall with historical advanced analytics without any artificial intelligence embedded into it is, it takes modeling. So you got to determine what's the best statistical model to use and method. That took a data scientist, and the data scientist was heavily dependent on a domain expert of the asset to be able to guide them to, what's normal and what's not. Both those individuals are usually very hard to get a hold of, very, they're very in high demand. So scheduling their time is difficult. So it takes up a lot of time. And then when they're done, you got to, configure a pretty complicated rules engine to take their findings and put it into a product. And the problem with all that is, when you're done with all that effort, all that expense, you're still only addressing a fixed set of problems. So whatever the data scientist, domain expert, and the methods have identified, that's it. That's etched in stone until there's another investment in time by these individuals for more findings. All right, so pretty interesting, but has a lot to be desired. So here comes our first polling question. So I'm very curious to know if any of you have tried a preventive maintenance solution in the past, or if you're currently using one. And then if you have, how satisfied are you? Do you think it's met its ROI to date? So I'll give you about a minute here. I know in my previous experience, a lot of times these predictive maintenance solutions have fallen short. All right. Okay, Michaela, why don't you go ahead and close it. We'll get the results here momentarily. You should be able to see this to the right of the WebEx screen. I understand it takes about 20 seconds for the answers to be compiled. And there we go. And, Interesting. So, yeah, I think that's pretty much par for the course there. So very good. So based on that, I think you're going to be very interested in what I have to say in the coming slides. Okay, so let's talk about change enablers. So there's been a lot of change in this arena. So what's driving it? Well, the obvious one is, just the competitive natural forces that's in all of us who's in business. That's why you're attending this webinar. I would think you're trying to find ways to be better, to get a leg up on the competition. The software vendors and solution OEMs that develop these predictive maintenance solutions are no different. They're always looking for the next way to get one up on the competition. So there's a continuous drive to be better, quicker, faster. Then you have the whole Internet of Things, and the Internet of Things it's real, and so just think about it. So the sensor networks are so much better, faster, robust, secure now. All sensors pretty much come standard, ready to be plugged into a sensor network. So networkability of those sensors is much quicker. Smart devices, all the instrumentation nowadays, panel meters, flow gauges, whatever, they usually come with the Ethernet port on them, where you just plug them right onto the Ethernet, the industrial Ethernet network of a facility, pull data back. And then computing power. I mean, I read recently where the iPhone 6 has got more computing power than the original space shuttle. So computing power, as we all know, has come a long way and continues to evolve. Then you have the whole introduction of cloud services. And what I'm talking about here is the software as a service model. So, the old paradigm of, buying a piece of software, unwrapping it, finding, getting IT to stand up a box for you, installing it, going through the configuration, going through the training, all that kind of good stuff. That was, a very painful startup, lots of cost, and very hard to maintain, especially with, the aging workforce and the loss of resources that I think we're all experiencing as people start to retire. So this is cloud services is, 180 degrees different. It's a whole new paradigm. You basically, the service provider takes care of the installation, takes care of the configuration, the purchasing of the software. All you basically do is go to a portal once you make your data available and enjoy the solution. So it's far more sustainable. You take that and you couple it with artificial intelligence. So the technique that we're going to be focused on and has been the deliverer of the evolution that I'm going to talk about here is machine learning. So machine learning, if you don't know much about it, it's the top AI technique used in advanced analytics. So when the young, bright data scientists that come out of the universities nowadays, machine learning is the #1 technique they have in their back pocket to go apply to the world that they're about ready to enter. And the #1 contribution of machine learning for predictive maintenance is pattern recognition. We'll talk about why that's so important here in a little bit. And to give you some insight, this technology, this machine learning is used by Google for their self-driving cars. It's used in all the voice recognition software, the contemporary voice recognition software, Siri being, I think the most recognizable one. It got it cut its teeth in the credit card fraud detection applications. And this is, the next bullet is what really surprised me. Okay, so this isn't, a few global conglomerates, the big analytics companies who have these in a vault. When I say these, the algorithms, the AI machine learning technology, on the contrary, it's publicly available on the public domain. And like I say, all the data scientists coming out of the universities have it in their back pocket. If you do a Google on it, you'll find a Machine Learning for Dummies book with algorithms published right in the book. So it's just amazing. So these things are, this technique is making its way into the mainstream in a big way, and it's here now. Which leads us to the next evolution. So with AI, and as it makes its way into predictive maintenance, and it's here now, these solutions are available today. It now, with these solutions, you don't have to determine the data model. It does it for you, or the actual statistical model to be used. You don't have to you don't have to have a data scientist and a domain expert studying the data to figure out where's the anomalies. It self-discovers the anomalies. And thanks to the software as a service and other bundled solutions, there is no rules engine to configure. It's done for you. So it's a much simpler way, and it's a way that we're going to talk about that will give you richer results than what has ever been achievable before. So let's talk about a little bit, let's start delving into how it works. Okay, so you see the stream, the connect, import, combine, analyze, present. So the first thing you have to do is connect the data. And the primary data sources are the sensor streams, and these are typically, the sensor streams are brought into what's called a process historian. It's a platform out there, OSI Pi, AspenTech IP21, Factory Talk Historian, Prophecy Historian. Those names, if any of those ring a bell, that's what the historian, process historian layer is doing. It's taking that sensor data in and it's time and date stamping it. Then you have the maintenance records and the maintenance history. So that comes from the computerized maintenance management system, or CMMS as it's called. So these are like the Maximos, the SAP PMs of the world. Vanis is another one that's popular out there. So it takes the maintenance records of an asset. So what is the work order history? It goes out and finds the corresponding sensor data for that work order time and history, and the post data going up to that work order. It combines it, analyzes it, and then presents it in when a predictive event is detected. So very, hopefully that's easy to get your heads around as to how that happens, and we'll talk about it a little bit more in the coming slides. But first, second polling session here. So we're very curious as to know how many of you have got process historians in place today. Again, the voting's off to the right there. So the process historian, again, if you've heard, the term, Pi or IP21 or Factory Talk, or maybe Wonderware Industrial SQL, that's what we're talking about. How many of those do you have? How many of those do you have? How many of you have those in place right now is what I'm looking for. And then, do you have a current maintenance work order history? So do you have a CMMS package, a Maximo or a SAP PM module? And then, if you don't have a maintenance system, but you're recording your downtime, and you got a good downtime history, either in an alarm event engine or a downtime tracking system, that can be used as well in place of the maintenance management system. So curious to know how many of you have those. If you have both, all the better. So I'll give you a few more seconds. All right. Okay, Michaela, you have to close the voting. We'll let the system compile the results. Okay, excellent. So I see that among the participating community here on the event, the majority of you have historians. You have a maintenance management system and downtime tracking. So that's important. You have the basic infrastructure for this solution to be plugged into. So very cool. Okay, so just staying, going the next level deeper as to how this works. So you have agents, and agents is, this is the concept of an agent has been around. The traditional advanced analytics solutions have this, but this takes it to the next step. You have these agents, and they're autonomous. So, you have two types of them. You have a failure agent. So this is an agent that watches, for a pattern that's been identified already. As, based on historical data, it's recognized as a failure condition. And then the real, differentiator here, in my opinion, is the anomaly agent. So now you have an agent that sits there for, continuously monitors that data signature of the asset, and it's looking for an anomaly. It's looking for a pattern that's not known. So it's not normal, and it's not within the recognized failure patterns. It's something outside of those known patterns. And that's where you have the continuous learning of an asset. All right, it's key. So going back and, next level down for how it works, you have the technology has to learn the patterns, all right? So what it does is it goes back into that work order history or downtime history, and the more history you have and the more events that are the same throughout that history, the better. So this particular example is showing that the data is showing two instances in history, once in 2013 and again in 2014, where this occurrence, this downtime, this disruption happened. So it takes that and it learns from that data. And then it goes in from there, it can watch for that data, and there's simulations that will test it to make sure that it's, it repeats the pattern it will detect. And the exciting thing is the advance of the detection. There's up to like a 30-day notice that this technology is capable of doing. So absolutely phenomenal. So, if you look at, why these agents are important, the old way is, a single sensor. So this is the maintenance paradigm, the condition-based maintenance. You're looking at a sensor, waiting for the sensor to tell you when it's ready to go. But with anomaly agents, you can look at multiple sensors and detect, just minuscule interactions between them. And that's what gives you the advanced warning. And if you want to close loop it, you can actually tie this technology into your maintenance management system to automatically issue a work order. So think about it. So, what does that mean? Well, the sooner you can detect or the earlier you can predict a failure, the less costly it is going to be to repair it. I mean, think about it, if you're waiting for it to get close to failure mode or in the failure mode, you're most probably disrupting your operations, so you're stopping production in an unscheduled manner. You're most probably expediting parts maybe even expediting a service provider to come in and help fix it, or maybe the original equipment manufacturer, all very costly. Just think if you could have a 30-day window as to when that's going to happen. Well, now you can schedule it and get everything staged, and life becomes far easier, as I think you would agree. Okay, so staying with the historical approach, the traditional way is, you develop an agent, and it's it just continuously looks for one pattern. One pattern, for that the data scientist and domain expert has discovered, and it's going to just sit there and it's going to look and it's going to monitor for known, for a known fixed set of data patterns. All right, that's cool. It's got value, but there's an evolution. Next, there's a better way yet. So when you look at the machine learning difference, well, when you right, so now it's continuously monitoring for previously learned normal. So it's always looking for normal, making sure that the asset is in normal operation. Then when it sees a deviation from normal, it starts comparing against known failure signatures. So if you have a known failure signature, you have sent out an alert well in advance, and operations can intervene in a timely fashion. So, you're fixing, a small problem before it becomes a really big problem. All right. But get this, it gets even better. All right. So now with, this anomaly agent, it's sitting there and it's looking for unknown anomalies. When it sees one, it sends out a health alert. It sends out, request an inspection. So an asset expert, usually someone in maintenance or an asset reliability engineer, will go out, take a look at that asset, and confirm that it's, it's something that is unique and could lead to failure, or maybe it's something that's just a new operating, pattern, and it's fine. And if that's the determination, which this illustration is showing it is, then they just retain that pattern as a normal operating pattern. But now, what happens if, it determines something? The asset specialist goes out there and finds out, hey, this is something new, and yeah, this is going to lead to failure. And, this is going to be, now we have yet a new failure pattern to add to our library that the agents can continuously monitor for. And the cool thing is that this is giving you, a 7-day alert. Once it's defined as, a known pattern, you'll get a 30-day failure signature alert from that point moving forward. But you can see how this technology allows you to continuously learn and to continuously get better, at this predictive capability. So when you can deploy, as many of these agents as the technology detects signatures on. So each signature requires, each failure signature requires a new agent. The cool thing about this is this technology is you can also go upstream and downstream of the process of your sensor stream. So now you can look at, the incoming effect of maybe material or flows, or the output, downstream conditions. You can bring that, you can cast a wider net for these data agents to look at. And the other thing to think about is when you have a fleet of similar assets, this is where it really becomes attractive, all right, because you can really capture a lot of ROI because you're making all your investment up front on, the one asset, but now you can take these agents and propagate them across your fleet for monitoring of the entire fleet. Which leads us to our third and last polling question. So I'm very curious as to how many of you have got, similar asset types that can be grouped in as fleets, or are all your assets, individually unique, or do you have some of both? Again, depending on the cost of the asset, the fleet approach has the best bang for the buck, but if you have a, a very expensive single standalone asset, this is also has its value as well. So I'll give you a few more seconds. Okay, Michaela, if you could close the voting. Let the survey machine crunch the numbers. We're going to go into some use cases next, where we're going to talk about the success that other companies have had with this. All right, outstanding. Very good. So I would say that with those results, we have a very appropriate audience for what we have here. So just talking a little bit about, what all this adds up to. So imagine now you have machines that stop breaking down. Just think about that. No more unplanned, scheduled breakdowns. I firmly believe that this technology has got the capability of delivering those results. Machines last longer because, they're not going through dramatic breakdowns. Net operating, your net output increases dramatically, so your operations gets more profitable. And your maintenance costs decreases dramatically. That's, what we're all about here in the maintenance world. So case studies. Let's talk about some interesting insights from what other companies have done. And I'm going to start out with, the real big assets and then kind of work our way down. So the first one is a locomotive company. So locomotives, the number one, the biggest thing in the locomotive is the diesel engine. These locomotive, the transportation companies, when they have a failure of a locomotive in operation, it is an extremely expensive event. From what I understand, it's like a couple $1 million per event because you have to send, 2 locomotives out, one to pull the old one away, the other one to hitch up to the freight and continue hauling it. But the real expense comes in the penalty that the line owner issues for holding up operations. An extremely expensive fine. So this locomotive company was experiencing these downtimes, in-line, in-service downtimes. They engaged a couple, analytics companies, well-known companies, to come in and basically start up, what they called a science project. And this was the data scientists and asset professionals pouring over data, seeing what they can find. And from what I understand, it went on for a couple years, and the results was less than impressive. This machine learning-based technology was deployed, and in 7 days was able to discover more anomaly patterns and insights than the other 2 companies did in a couple years. They put it online, and they haven't had any failures since. And, the savings during the trial was like $10 million. Projected savings, annual savings, about $200 million a year. So this is huge. So, this is one of the things that turned this freight company into believers. The autonomous agent detected a degradation in the oil chemistry, and they were saying, "Hey, this is going to be a problem here." The technology sees a failure. Management kind of balked. They, here we go again. Here's another, science project, erroneous prediction. But just in case, let's go ahead and run a high pressure test just to see if this is, just see if it validates. And they ran it, and the high pressure test confirmed that there was going to be a pending failure. So this was very impactful, and this company is enjoying great success. Next one down. So not as big an asset, but a very popular asset, a compressor. So this is a compressor on an oil pipeline or gas pipeline. They've had decades-long issues with the compressors, despite millions of dollars spent on vibration analysis and RCM studies. They still were experiencing downtimes. So they brought in this technology. It cast a wider net. Like I was talking, they not only were they looking at sensors on the compressor, but they were looking for the intake and the outlet of this compressor, so upline, downline. And they were able to, the technology was able to determine the root cause detection of basically liquid getting in to the compressor from the upline material flowing in. And a statement here from the chief rotating engineer, basically talking about how you just didn't have enough people to execute this kind of level of monitoring and analysis that these autonomous data agents do. So they were, here's one where on the same compressor, same company, they were able to determine a third stage valve issue. It gave an alert 8 weeks in advance of what the vibration detection equipment was suggesting. So millions of dollars of savings and repairs and lost product. All right, third and last use case. This is going down against a smaller asset. This is a electric submergible pump. This particular company was pumping oil, and they were having a lot of breakdowns. They have a big fleet of these things, like 400 of them in the ground across the country. And every time one of these breaks down, it's like a $500,000 cost in repair, and it's oil, so if it spills, it's very costly environmental impact. So they did they brought in a couple companies. One of our partner companies was asked to participate, and they were able to beat out their competition by a large margin in just the number of faults they were able to detect and the clarity and the detail that the technology was able to provide. They did an online trial with 18 pumps. It's been very successful, and they're going to roll it out to the other 400. And the success that they initially are seeing is around the cause of, or the data signature leading up to a cracked casing. A case leak is an extremely costly failure because of the environmental mess it makes. So they've determined, the technology has determined what that data signature is. It's a major save, and they're breaking it out, rolling it out to the other fleet of pumps. So hopefully that gives you some insight as to just the dramatic results that these machine learning predictive maintenance solutions can have. And with that, I think it's time for Q&A. So you should have a Q&A button off to your right if you want to ask any questions. I'd be happy to answer.
Okay, Tim, I do see some questions already filing in, so if you want to go ahead and start with any of those questions, we can work our way down.
All right. All right, so there's a question about what type of sensors are typically used. It obviously depends on the asset type. But it's anything from, flow, temperature. If you have vibration analysis equipment, we can bring that into the equation. Also if you have a fluid process, so the viscosity of the product going in, product going out, those type of things. And then if you have, there's a question here about if you have work order history in SAP, can it be used? Absolutely. If you're using the SAP PM module, these technologies, the one that I'm familiar with has got built-in native connectivity tools that will connect to SAP PM, Maximo, Advanis, and automatically query that system for those work order histories and brings it in. So yes, SAP is a great solution that we can leverage. There's a question here about what are the top 3 issues with sustainability of ROI as it relates to the companies who have implemented this type of software. So in the old days, before machine learning, where you didn't have the continuous, learning, then it was only as good as, the fixes that it found. So there was, I think that the dissatisfaction came, by, companies spending hundreds of thousands of dollars on these predictive analytics solutions, but they still experienced downtimes. So, there was a clouding of the ROI. With this machine learning-based technology, since it's continuously learning, you can head off those new downtime, instances before they happen, which really greatly impacts the ROI, keeps management happy that their investment was a good one. And looking through here. And then there's a question here, how does the software eliminate nuisance alarms? So it's all around the patterns that it has learned. And if it's, there are filters built in that you can implement. But in general, by comparing it with what's normal. So it's very important to have a good sensor array in data feed on what's normal to make sure you have a good baseline so you don't, the anomalies are well captured as, normal when they are normal, and then failures as when they're failures. So there's a question here about benchmarking, machine learning techniques performed against standard techniques. That is something that, whoever answered that question, if you want to send me an email right there, I can get you some information on what's been done. But I will say that typically the way these applications are evaluated is they're benchmarked against, an existing solution. What happens is we take the data, we do a data pilot. So we take the data from the process historian and then the event engine, whether that be a CMMS or a downtime system. We take it, put it in offline mode, and we take a look at what the anomalies are, from a data pattern perspective. And then we see what the technology gives back. And typically, that's a great way to benchmark if you have another solution in place. The locomotive story is a good one where they had 2 global leaders in predictive analytics working on it for a couple years, and this was put in place, and in 7 days was able to have better detection than what those two companies had in over 2 years. And there's a question about, does the software require tuning over time? Yes, it can. And this is where the bundled, services solution that's available now from a number of companies, where, that's part of their service, is that continuing tuning of the software and the agents based on, maybe new conditions that weren't present when it was originally built. And there's a there's a question on whether you can use a control and automation system like a DCS. Absolutely. So it's in fact DCSs are a very popular source of data for these type of assets, especially when you're looking in the continuous and batching industries. DCSs are a very popular source for data feeds into the process data historians. Just looking through, I think I've got pretty much everybody's questions addressed, Michaela.
Okay, great. Well, I do appreciate everybody that did attend today's webinar. I've had quite a few questions of people asking me if we did record it, if you missed any portion of it, or you want to share this webinar with any of your colleagues. We did record it, and we're going to get it up online soon, and I will send you a link via email for you to rewatch or to share the webinar. So be on the lookout for an email from me in the coming days with that link. And like I mentioned at the start of the webinar, there will be a survey that will pop up in your browser when you exit out of this webinar. We ask you to just take a couple minutes to fill it out. We do read each and every one of those responses, so we do appreciate the time you do take to answer those surveys. And this concludes our webinar. We hope to see you in one of our future webinars. Thank you so much for participating. And thank you, Tim.
Yes, hey, thank you. And again, please feel free to reach out to me. I'm on LinkedIn. You have my email address on the previous slide there. If you have another question or something to get answered in enough detail, please let me know, and I'll make sure I get you the right answer. With that, thank you so much for your time.
Great, thank you.